Good morning. So today we are going to start on this new chapter of vectors. This is not a very new chapter to you guys because I believe you had to study for it when you were preparing for the assignment. So with the definitions, with the basics, I won't go into too much detail about that because you should already know what a vector is, what the magnitude of a vector is, what a unit vector is, and all those things, especially with two-dimensional vectors, because that was in your assignment. So what I will be doing for today is, and for the classes that come until we're done with this chapter, is we're just going to go over the questions in the textbook, because that, I believe, is the best way to prepare or to learn a topic, by answering questions. So let's get into it. So very briefly, I will just go into what a vector is. Just like you did in physics, you see a vector has a magnitude and a direction. So it has a magnitude and it has a direction. So magnitude is the size, you say this is how big it is, and a direction, you can say it's moving from left to right. Usually we represent it with an arrow like this. It has a starting point, let's say A, and an end point, which is B. So the length AB, that is its magnitude, and the direction is the direction in which the arrow is pointing to. So there are several ways that we represent our vectors. So let's say this is our vector AB. So that's supposed to be an arrow on top. So AB, that means it starts at a point A, it ends at the point B. So, and the arrow shows that it is a vector. So this is how we represent it. We have row vectors in two dimensions. We have X, Y. This tells us how many units it's moved in the X direction, how many units it's moved in the Y direction. Then we can represent it as a column, for example, X, Y. So again, this is two-dimensional because it has X dimension, Y dimension, and then later on we will look at three-dimensional vectors. So this is row vector. This one over here is a column vector. Then we also have another way that we represent it, that is in terms of the unit, in terms of unit vectors. But before that, we should say that the magnitude, this is the size or length of a vector. And if I have a vector AB, we represent its magnitude like that. So it's like it's in absolute value symbols. And the way we calculate the magnitude of a vector is just x squared plus y squared, and then the square root of that. So it's like you're working out distance, okay, but it's just x squared minus y plus y squared, and then the square root of that. That is the magnitude of our vector. Now, a unit vector has magnitude of 1. Okay, so that means when you work out the magnitude of that vector and you get 1, that means that is a unit vector. So we have standard unit vectors, the one that goes in the along the x-axis or is parallel to the x-axis, we call it I. So usually it's represented like that, then I with a hat. In your book, you'll notice that it's bold, but I think when I write it here and I make it bold, you won't be able to tell the difference really. Okay, and then there is J, like this, right? This one is along the y-axis. That means it is parallel to the y-axis. Okay, and then we have the K. That one we will talk about when we start with three-dimensional, but this one is along the z-axis. Okay, so usually, like I said, in your book, you'll see that it's bold, but here, just to differentiate the letter I from the vector I put a hat, or sometimes you will see it's underlined, so I like that, J, K. Okay, again, this is just to distinguish them from the letter and show that it is in fact a vector. It also might have an arrow like this one over here. So a unit vector is just a vector that has a magnitude of 1. And every vector can also be written in terms of its unit vectors. So for example, this vector here, AB, I can write it as xi plus y times j. So remember, x and y, these are just numbers. So you have x times I, y times j. So these are the three ways that we write our vectors. This is row, this is column, and this is in terms of the unit vector. Then we have displacement and position vectors. So here it's easier to see if we have a diagram. So let's say this is my x-axis, that is my y-axis, and I have a vector over here. It starts at a point A, it ends at the point B. Okay, so this is my displacement vector because it starts at some point A, ends at the point B. Now if, just a moment. Okay, sorry about that. Things always come up that you must deal with. Anyway, so this is what we would call a displacement vector. It starts at A, goes to B. Now, if I were to take this vector, okay, let me just copy it the way it is. Okay, so I take this vector, and what I do is I move it over here. You can see I've not changed anything about the vector. The size and everything is exactly the same. Just a moment. Okay, so like I said, the vector is the same except that it is at a different location. It is still exactly the same vector, except this time it starts at the origin. So I have moved it, and it now starts at the origin and ends at another place, let's say C. The vectors are exactly equal in length. They are pointing in the same direction. If I were to measure the angle with the x-axis, it would be exactly the same, except this one starts at a point A, ends at a point B. Now this one starts at the origin and ends at the point C. So this one we would say is a displacement vector. This is a position vector. Now, a position vector must always start at the origin, okay? So if I give you a displacement vector, you can always rewrite that as a position vector, okay? And we'll look at how to do that later on. But the way to do it, maybe let me just say, if you should think of vectors as moving from one place to another. Like here, I've been saying you move from A, you go to B. All right, now if you want to work out the position vector, let's say I want to rewrite AB in terms of its position vectors or as a sum of position vectors. What you should think of it is I start at A, I go to B, but I must include the vectors OA and OB. OA means from the origin to A, and OB is from O to B. But again, like I said, we'll look at examples of that later on. Then we have vector arithmetic, where you can add vectors. So we can add vectors. And the way you do it, if I have two column vectors, two row vectors rather, and I want to add or subtract them, the answer is just add the x and the c, and then add the y and the d. So you add the corresponding elements. So if you're adding or subtracting, you just add the x and the c. That becomes your x coordinate, if you will. The y and the d, that becomes your y coordinate, if you will. Okay, so that's how we add vectors. You add the corresponding elements. You can only add vectors that have the same dimension. So you cannot add a two-dimensional to a three-dimensional unless you turn the two-dimensional into three-dimensional. But we'll look at those again. Then we also have scalar multiplication. With scalar multiplication, let's say I have a scalar and I want to multiply it by this vector AB. All I do is this k will multiply in there, this k multiplies in there, and this is just KA times KB. So what happens to a vector when you multiply it by scalar? If it's positive, it stays in the same direction and it just stretches. That means if it's bigger than 1. If it's negative, the direction changes, but they are parallel. Okay, so we say that two vectors are parallel if they one is a scalar multiple of the other. Okay, so we look at equal vectors. Vectors are equal if and only if they have the same magnitude and the same direction. So this is the only time that vectors are equal. If I was to switch this around and draw a vector from B to A, it is no longer equal to OC because they are not in the same direction. Vectors must be in the same direction, have the same magnitude. Just a moment. Okay, so as I was saying, equal vectors have the same magnitude and the same direction. So these two vectors are equal, even though they are not at the same position. One is going from A to B, the other one is from O to C, but because their magnitudes are the same and they are in the same direction, therefore these two vectors are equal. Then we say parallel vectors. So we talk about parallel vectors. Parallel. Okay, vectors are parallel if and only if say they are scalar multiples of each other. Okay, so one is a scalar multiple of each other. So if I have a vector here, AB, it starts at A and goes to B, and then I have another vector from O to C. We say that these two are parallel if and only if AB is equal to some constant multiplied by OC. So if I can find a number that when I multiply OC by that number, I get AB, then the two are parallel to each other. It doesn't matter whether the number is positive or negative, as long as this is a real number, not zero, obviously, then the two vectors are parallel. Okay, so an example is, let's say AB is equal to 2, 3, and CD, and this is equal to 4, 6. Now, because I can rewrite CD as 2 times 2, 3, this is just 2 times AB, then AB is parallel to CD. Okay, so as long as I can write one as a scalar multiple of the other, then they are parallel. I could also rewrite this one, take half out, then I would have 4, 6, then it's half of CD or half times CD, then I say they're parallel. Okay, so as long as one is a scalar multiple of the other, then we say that the two are parallel. Then there's also collinear vectors. Now, collinear, like we did with coordinate geometry, we said vectors are Vectors are collinear if they must have a point in common. So if I have, this is one vector, and then I have another one. This is L, K, let's say M. I have two vectors here, let's say LM, and then I have another vector, KM. Okay, so you see that these two vectors have a point in common. They have M that is in common. Now we can check if they are collinear by checking whether they are parallel. So there are two things that we need to check that vectors are collinear. First of all is that they must have a point in common. Then they must also be parallel. So just like we used to check with 3 points and say, are these 3 points collinear? You would check the gradient, and then there's a point in common between the two lines that you would draw. Then you would say that those 3 points are collinear. So here they both have M in common and they are parallel. If I say this is parallel to that, then this vector LM and KM are collinear. If they do not have a point in common, but they are parallel, it does not mean they are collinear, because just like these two vectors over here, AB and OC, they are parallel, but they don't have any points in common. Therefore, these two vectors are not collinear. So you need to show that there's a point that they have in common and they are parallel to each other. Then your vectors are collinear. Okay, so that was on collinear. All right, so now let's get to the exercises. So as I said, the rest of this chapter, we are just going to be going over the questions in your textbook. As I always say, you just need to practice. That is the best way to get the hang of it. So I will start with exercise 8A.3, and this is on vector diagrams. Let me see if I have a question here. Okay, now with vector diagrams, what you should know is, or how you should think about it is, you're always trying to get from one point to another. So if we look at the first question in 8A.3, we are given a diagram like this. Something like that. Okay, not quite like that. This is the point A, this is the point B, this is the point C. We're told that this vector is B, so I'll put this is a vector B. In your book it's in bold, but I can't make mine bold there, so I'll underline the B. And this vector AC, we are told, is A. And we are told that there's a point D over here that divides the line CD in the ratio 1 to 5. And then we have to find or express the vector CD in terms of A and B. Okay, so this is what we are given. Now, when I ask you to find CD in terms of A and B, all I am saying is, how do you make your way from C to D? Now, the way you make your way there doesn't actually matter. You can take whatever direction you want, you can take whatever turn you want, as long as you start at C and end up at D, and then represent all those paths that you take correctly, your answer will always be the same. So what I mean by that is, somebody can start here at C, they go to A, they go to B, then they go to D. They will get an answer, simplify it, and then another person would say, okay, what if I go from C straight to D? They will get an answer, it will be exactly the same. Then another person will say, what if I go from C to A and then to D? You will get the exact same answer. Now, the reason why sometimes you don't take the most direct path is because you don't know what that path is. Now, for example, I know that from C to A, there's this vector that represents it. There's this vector A over here. So it's a path that I know. Otherwise, I could have just gone from C to D, but I don't know what this vector from C to D is. I know what C to A is. I know what A to B is. So those are the paths that you use. So you always want to use a path that you know. And like I said, it doesn't matter if I go from C to A, then I decide, okay, let me go back to C, then I go back to A, then I go to B. In the end, when you simplify everything, doesn't matter that I went from C to A and then back, I will always end up with the right answer, okay, if I have done my charting correctly. Okay, so now first thing you should do is try and look at how you will get from C to D. Now what we will notice, or what we are told, is that CD, first D divides CB in the ratio 1 to 5. So this entire length over here, you can say we divide it into 6 parts, because there's 1 over here and there's 5 over here. And CD is just equal to 1 over 6 of CB. Okay, because it's divided in the ratio 1 to 5. So this length over here is 1 over 6 of the entire length of CD. Okay, now the reason I chose CD is because I can get from C to B quite easily. I go from C to A and then from A to B. So I know what CB is. That's why I'm writing CD in terms of CB. Okay, and then we say this is 1/6 CB. CB, we said I must go from C to A, and then after that I add, because that's part of my journey. Any new vector that I take, I keep adding, and then I add the journey from A to B. So this is plus A, B, like that. Okay, now these vectors here, CA and AB, are written in terms of A and B, so I now substitute. Now if I look at my diagram, the vector from A to C is this small a. That means the vector from C to A is negative because it is in the opposite direction. This vector from A to C is going to my right, and the vector from C to A is going to the left, so that is why CA will be negative A. So this is 1 over 6 negative of A, and then AB is just the vector B. So this is plus B, and this is negative 1 over 6 A plus 1 over 6 B. Okay, so that is what CD is. And the way we get it is you just need to work out the path from C to D. Okay, then the next one, we have AD. Let me just look at the question. Okay, we have to find the vector AD. Now AD, I'm gonna start here and I go to D. Now if you think about it, I can go from A to C and then use the path that I got in the previous question, which is CD. So what I do is I can go from A to C, and then I add the distance of C to D. So this one I want us to try it in 2 different ways and see if we will get the same answer. All right, so from A to D, we said we can go from A to C go from A to C. And then once I get to C, I add this one, C to D. The reason I add this C to D is because I already worked it out in the previous question, so that shouldn't be too difficult. There's not a lot of work for me to do. And AC is just this A over here. Okay, so now I represent, or I rewrite these two. Now AC, we said it's here in our diagram, it's A, so this is just A, plus CD, we say this is minus 1 over 6A plus 1 over 6B. Okay, then the vectors that have the same letters, you can combine them. This is A, that is A, those two you can combine them. This is 1A, and there's no coefficient or there's no scalar multiplying it. You assume it's a 1, or you should know it's a 1. And then you have 1 minus 1 over 6, that's 5 over 6. So we have 5 over 6A, it's an A, plus 1 over 6B. Okay, so that is how we would do that one. Let's just see, C, B. Yes, okay, that's fine. All right, so I say this one here, I want us to take a different path and see, will we in fact get the same answer? So we start at A, and as long as we end up at D, will our answers be the same? So this time, instead of going from A to C and then using the path CD, which I worked out in the previous one, what if I go from A to B and then from B to D? Okay, so let's see. So we are looking for AD. And I said for this, to go from A to D, I must first go from A to B. And then once I get to B, I'll go from B to D. Now notice this B to D is not given, this one over here. But what I do know is that BD is 5 over 6 of BC. Okay, so I do know that BD, so this is A to B, this is 5 over 6 of BC. Just the BC. Okay, that's what I know from the diagram. So this BD is 5 over 6 of the vector from B to C. Okay, and B to C, how do I get from B to C? I must go from B to A and then from A to C. Okay, so now I can substitute A, B, this is A, and then this 5 over 6 should remain there. And then we said from B to C, I must go from B to A. Let me just write, this is B to A. And then from A to C. Okay.
Miss,
Yeah. Hello. Okay, then BA. Yeah.
why did
Go
we
ahead.
choose A? Why did we choose A at AB then?
This small a,
Yeah.
okay, from the diagram. Sorry, why do I have B here? Ah, I see in my notes I've represented them differently. Sorry, you're right. Okay, this shouldn't be A, should be B. Let me just see if I've done it correctly here. I hope I've represented these correctly. Okay, I think what I was writing and the way I have it in my notes is a little bit differently. Okay, so this is B, so that's fine, that should be B. And then 5/6 from B to A, and then from A to C. Okay, so this is B plus 5/6. Then from B to A, that is minus B. So this is minus B. And then from C to A, this is A. Okay, so I hope I've substituted them correctly. Then this 5/6, you multiply it in. So you have B over here minus 5/6B plus 5/6A. Okay, so you collect your B's and your A's. So when I write this, I have 5/6A plus 1/6B. Okay, and let's see. That is exactly the same answer I got over here, even though I took a different path. So it's 5/6A plus 1/6B, which is exactly that. So the direction that you choose to go in doesn't actually matter, as long as every path you take, you represent it correctly. So yeah, that's how your vector diagrams will work. So as long as you write down, okay, I'm going in the direction the vector is going in, it's positive. If I'm now going in the opposite direction, then it becomes negative. Okay, so keep those in mind. The way you travel around your vector to get from one point to another does not matter at all. As long as you say, if I want to go from A to B, I can go from A to C, and then from C to B, I'll get the right answer. If I wanted, I could just say this is B, and you can try it. Go from A to C and then work out CB and see, is that also equal to B? It seems longer, but the final answer will just be equal to this B over here. Right, let's do the next one because we have a lot of them to do. This is number 2. Again, these are all questions from your textbook that we will be doing from now on. So we're told that we have a vector A, which is equal to OA. So these are position vectors. They start at the origin and at the point A. And then we have another vector B, also a position vector from O to B. And we have to write in terms of AB, the vector ON. And then we are told N is the midpoint of AB. Okay, so what you do, you sketch what you're given here. So you have your X and Y axis. So that's X. That is my Y. Then you have a point A somewhere here. You have another point B here. The position vector goes from the origin to A. That's to B. And then we are told that N is the midpoint, so we know how to find the midpoint. You draw a line connecting A and B, and right in the middle you will have N. Okay, so N is over there. All right, we are told that this vector here is A, and this vector here is B. Then we have to find the vector from O to N, this one here. That is the vector we are looking for. Now, the way we do this is just pick a path that you want to follow. As long as you start at O and end up at N, you will get exactly the same answer. So what I did is I said ON, this is equal to, so I'm starting at the origin. Then what I do is I go from the origin to A. So that means I must write this vector OA. And then once I'm at O, I go to N. So I add A, N. Okay, now what we need to remember, the fact that N is the midpoint of AB is very important. That means it divides the line AB in the ratio 1 to 1. Okay, so this AN is actually just half of the vector from A to B. So this is OA plus half the vector AB. And I'm using AB because I know how to work out the length of, sorry, how to work out the vector AB, because I know I can go from A to O and then from O to B. That's my vector AB. Okay, so now I've represented everything in terms of something I know. Now I can do my substitution. OA, that's the vector A, because it's pointing in that direction. I don't need to make it negative. So this is my vector A, and then half. Now AB, this, in order to get AB, I need to go from A to O. So let me write that. This is A to O plus, once I'm at O, I go from O to B. This is O, B. Right, continuing, this is A plus half, and then AO, that's now in the opposite direction of the small a, so it will become negative. And then OB is in the same direction as this vector B, so I just add the B over there. So this is A minus a half A plus a half B, and this is half A plus half B, like that. Okay. So that's how you would do it. You could try it the other way. You go from O to B and then B to N. You would see that just like we did with the previous question, the answer would be exactly the same. The direction you take doesn't actually matter, as long as the way you write your letters here, it makes sense. I'm going from O to A, and when I'm at A, I go to N. All right. Then that was number 2. Then number 3, still on exercise 8A.3. So for number 3, we have, we're told that B is the midpoint of PQ, or this is the diagram that we are given. Let me just draw it. So we have this diagram with Q, P, and O. Then we have a point B over here. We're told that B is the midpoint of QP, so it divides it in the ratio 1 to 1. And then we have a point A somewhere here. And we are told A divides OP in the ratio 2 to 1. So this is 2 and that is 1. And then we have another point C over here. And we are told C divides OQ in the ratio 1 to 3. So this is the information that we're given. We're also told that OP, this vector, we represent it with small p. So for my P and Q, I use P hat. You can draw a line under the P, that's fine. But I prefer the hat. Okay, and then OQ. This is Q, like that. Okay, some people also draw the arrow on top of P and Q. That is fine. Okay, and then we are told to express the following vectors in terms of P and Q. The first one is OB. Okay, so I need to go from O to B. Now, O to B, I must go from O to P. And then once I'm at P, I must go half the distance of P to Q. Okay, so I must go from O to P, and then half the distance from P to Q, I'll end up at B, because B is exactly halfway between P and Q. Okay, and the vector from P to Q, if I want to go from P to Q, I should go from P to O, and then from O to Q, because OP, this vector here, is small p, and OQ is small q. So this is equal to small p plus half. So I am going from P to O, and then from O to Q. So this is P plus half. PO, that's negative of this P. And then OQ is just Q. So this is half P plus half Q when I simplify it. Okay, so something to take note of. You should take note of, maybe you've noticed it already. If I have a displacement vector, let's say this is a displacement vector that's from A to B, and I want to rewrite this in terms of its position vectors, this is just equal to minus OA plus OB. Because if I'm at A and I want to get to B, I must go from A to O, which is just negative of O to A. And then once I'm at O, I go from O to B. So this is from a displacement vector, and you have to rewrite it in terms of its position vectors, because position vectors always start at the origin and go to a point. So you'll see these questions quite a lot. We'll do some more examples just for you to note here that a displacement vector from A to B is just minus OA plus OB. Okay, and then that was number 3 in our exercises. Let's look at 3B. We have to write OA or find OA. Now, to go from O to A, that is just going 2/3 of the way from O to P, because this is 2, that's 3. It's divided into 3 parts, so it's 2/3 of the distance from O to P. So OA is just 2/3 of OP. So this is 2/3 of OP, which is 2/3 of my little p. And then C is OC. So again, go back to our diagram, O to C. Now you can see OC is just 1/4 of the way of O to Q, because this is 1 part, that's 3 parts, there's 4 parts altogether from O to Q, and then from O to C is 1 part, it's 1 part out of the 4, so it's 1 multiplied by OQ. So 1/4 multiplied by OQ. Okay, so this is 1/4 of Q. And notice you must always keep the direction in mind. Okay, remember that OQ is going in that direction, and our vector here is going in that direction. If it had said CO, you need to remember that it's not 1/3 of OQ. It's negative, sorry, not 1/3, it's 1/4. It's not, if the question had said CO, you don't just say 1/4 of OQ. it's negative a quarter because the direction is different. So that direction part is very important when we're dealing with these vectors. Then D, we have to find AC. So we look at our diagram and try to find our way from A to C. Now, if I want to go from A to C, there's several ways that you can do it. You can go from A to P, from P to Q, from Q to C. That is perfectly fine. Nothing wrong with that. But I think it's easier to go from A to O because I worked out what OA is. It was B part, and then I know what OC is. So that's easier because I'm just using questions that I'm using solutions from questions that I solved instead of trying to find this PB, but you can do that. There's nothing wrong with that. Okay, so we say that AC, to go from A to C, I must just go from A to O, and then I must go from O to C. Okay, and this is negative OA plus OC. And notice this is exactly what I was saying in this note over here. I have a displacement vector that I'm rewriting in terms of its position vectors. So negative of OA, OA is 2 over 3P. So this is negative 2 over 3P. And then OC, this is a quarter Q. So I have a quarter Q, and I leave it like that because I cannot combine the P and the Q. So this is my final answer. So that is how the vectors will be done with our vector diagrams. I have some more that we'll just keep going over them. Hopefully by Friday we will be able to have done all the questions, and you will be ready for the test. So again, in all the classes until we're done, we'll just be doing the questions in the textbook. So if you have a copy, try and do them beforehand so that when I'm going over them, you'll be able to follow along and see if what you did is correct. Then the next one is number 4. Number 4, we are given a diagram like this. I'll try and draw it as best as I can. This is C, this is O, this is B, this is A here, we have K there, and then we have L. Okay, and we are told that OK is equal to 2 OA, and OL, this is 3 OB, and OA, this is A, and OB, this is little b. Okay, so this is what we are given in our diagram. Then the first part, or the first question says express OK and OL in terms of A and B respectively. So the first one, A, we have to write OK in terms of A and B. Now if I'm at O and I want to get to K, here I'm just going to make use of this information that I'm given. I'm told that OK is 2 times of OA. So here I 2 times OA, which is just 2A. OA is small a, so this is just 2A. And then also we have to express OL in terms of A and B. So OL, this is 3 times OB, and this is 3B. Okay, so let me just use a pen. So this little vector here is A, and that little one over here is B. Okay, then the next question. It says express BA in terms of A and B, little a and little b. So we go back, you're at B and you want to get to A. So if you think about it, if you're at B, you want to get to A, first go from B to O and then from O to A. So this will just be minus B plus A. So when we write this down, we have BA, this is negative OB, which is just the opposite of BO, and then OA. So this is minus B plus A. Okay, and you can rewrite this as A minus B. That's fine. Then C, we have to write LK in terms of A and B. So we have LK. So we'll go back to our diagram. LK, so you're here at L and you want to get to K. So you can go from L to O because we know what OL is. So that's negative OL. And then once you're at O, you go from O to K. So it's just minus of this plus that one. Okay, so it's the negative of OL because you're going in the opposite direction, and then you add OK. So LK, this is negative of OL plus OK. And this is equal to minus 3B plus 2A. Okay, then I just rewrite the positive one first, but the way I've written it above is also correct. It doesn't necessarily have to be the positive one first or the one that comes first alphabetically first, but it looks nicer that way. And then D, we have given that, so we are given some more information. We're given that BC is equal to 4BA. Then we have to express OC in terms of A and B. So we're told that BC, okay, BC is 4BA. So BC is 4 times of BA, is 4 times of this. Okay, so we need to find, okay, so let's just rewrite that. We need to work out OC. Again, that's not too difficult to do. So we know that OC is just equal to OB plus BC. Okay, so I'm trying to get from O to C. I can first go from O to B and then B to C because I know what BC is. BC is 4 times of BA, and I've already worked out what BA is. Okay, so I just substitute. Now OB, we say this is our little b. Okay, so there it is, that's little b. And then BC, sorry, BC is 4 times of BA, and BA is over here. So this BC is 4 times of BA. So I just substitute this A minus B over here. A minus B. And this is equal to 5A minus 4B. Sorry, that's not right. This is 4A plus 3B. Yeah, that's correct now. Okay. All right. Then E, we have to work out LC. Okay, so to work out LC, I'm trying to get from L to C. I'm trying to get from L to C. I can go from L to O and then from O to C, because in the previous question I just worked out what OC is. Okay, and I know what OL is here. It's 3B. So this one is not too complicated. LC, this is equal to negative of OL because it's in the opposite direction. And then I add OC. So I go from O to C. And this is equal to negative of 3B plus 4A minus 3B. Then you just combine your like terms. This is 4A minus 6B. And that's it. And then F says use the vectors LK and LC to show the points LK and C are collinear. So I want to show that these 3 points are collinear. So you can see already that LK and LC have a point in common, that's L. So what I do is I just show that the two are parallel. And to show that the two vectors are parallel, all I need to do is show or rewrite one as a scalar multiple of the other. So two vectors are parallel if and only if they one is a scalar multiple of the other. So I know that LK is over here. It's 2A minus 3B. This is 2A minus 3B. And I know that LC that I just worked out now, this is 4A minus 3B. So what I will do is I'll rewrite this LC. I will factor a 2 out. So this is 2A minus 3B. This is 2 multiplied by LK. Okay. Okay, sorry. So you can see that this is 2 of LK. So then we can say that LK is parallel to LC. Therefore, the points are collinear. Okay, so by definition, so remember you need a point in common. You see this vector has L, this vector also has L, and then you must be able to show that one is a scalar multiple of the other. So it must be two things, point in common and that they're parallel. Just being parallel is not enough to show that the two vectors are, so the 3 points are collinear. Okay, so that is that one. Let's move on, see how many we'll be able to do today. And number 5, we are given a diagram. Let me draw that. Let's extend it like that. Okay, so we are told that in this diagram we have OA, so this vector like that, OA, this is small a, and OB, this little vector here, OB, this is small b. So those are unit vectors. And M is the midpoint of OA, so it divides OA in the ratio 1 to 1. T lies on AB, so T is over there, it lies on AB such that AT, so that AT, this is equal to 2 over 3 of AB. Okay, so 2 over 3 of AB. So it divides this line, AB, in the ratio 2 to 1. Okay, so I hope that is clear why it's the ratio 2 to 1. So here, if I want to get AT, it must be 2 over 3. So if there's two parts here, there's only one part missing. That's why it's the ratio 2 over 3. Okay, and this is how the diagram is. Then the first question says, express AB and AT in terms of A and B. So we need to find AB and then AT. So AB, we said, is just I would go from A to O and then from O to B. So that is the negative direction of OA, and then from O to B. So this, okay, that's fine. This is negative OA plus OB. Okay, and then OA, we know this is negative A, and then OB, this is just B. So I can rewrite this as B minus A. Okay, and then we also have to work out AT. So AT, we are told this is 2 over 3 of AB. And we just worked out AB in the previous question. So this is 2 over 3 of B minus A. This is 2 over 3 B minus 2 over 3 A, like that. Okay, then B says express MA and MT in terms of A and B. So MA, okay, we know that MA, this is half of the distance from A to M. So this is half of the distance from A to O, sorry, from A to O. That's what it is. And this is half of the distance of the negative of OA. So this is negative half OA. We say this is A. So that is what MA is. Sorry, I'm getting my directions wrong. MA, we're going from M to A. So that's half of the distance from O to A. So this is not right. Okay, so this negative does not belong there. Okay, now it's fine. Okay, so again, be careful with these directions. Very easy to make a mistake. And then we need to work out MT. Okay, now from to get from M to T, I can go from M to A, because I just worked out MA in the previous question. And then once I'm at A, I go from A to T, because I worked out AT in the previous question, Okay, MA, we say this is half of A, and then AT, we said this is 2 over 3B minus 2 over 3A. Let me just check if that's right. Yes. All right, then you combine everything. We have a half A minus 2/3 A, so that's negative 1 over 6A, and then we have 2 over 3B. Okay, then C, we have to work out. C says if Y lies on OB produced such that OB is equal to BY, express MY in terms of AB. So this produced just means you're extending the line from O to B until you get to a point Y such that the distance from O to B is the same as the distance from B to Y. So this would mean that B divides the line OY in the ratio 1 to 1. That's basically what it means. Then what we need to do is express MY in terms of A and B. Okay, so what we need is MY. Right, so you're at M and you want to get to Y. What you can do is you go from M to O, and then from O you go to Y. So here, this is said M to Y, M to O, and then you go from O to Y. Now M to O, this is negative of OM, and we know what OM is. And then this is OY. Now O to M, we work that out. We said, we didn't work it out, but we know that it is half of O to M. This is half of O to A. Okay, so this distance O to M is the same, or this vector here, O to M, is the same as the vector from M to A, because M is the midpoint of OA. So the same thing will be true here. This vector from O to B is the same as this vector from B to Y, because B is halfway of O and Y, and they're facing in the same direction. Okay, so MA is exactly the same as OA, OM rather. Okay, so minus OM This is minus half of A. And then OY, this is 2 times of B. So go back to our diagram and see why is it 2 times of B. We know that from O to B, this is OB, and this vector here is equal to that vector there because that's the midpoint. Therefore, I have B here. And this will also be B. And just like I had half A here, this is also half A there because the entire vector must be equal to A. So if this is B, it's halfway in the same direction, that is also equal to B. Right. Sorry, okay, I think that's fine. So when we add or simplify it, just want to rewrite it with a positive 1 first. This is just 2B minus half of A. Right, that was C. Then let's look at D. Now D says show that MT and MTY is a straight line. So this is like a roundabout way of saying that show that MT and Y are collinear. So if I say show that these 3 points make a straight line, I'm just asking you to show that the 3 points are collinear. Now the way we do that is just like we did in the previous questions, we show that one is a scalar multiple of the other. They have a point in common. So find 2 vectors that have a point in common, and then from there you show that one is a scalar multiple of the other. So I start with MY. MY, we worked it out already. This is 2B minus half of A. Sorry, my B is not underlined here. Okay, then what I can do is I can factor a 3 out. So if I factor 3 out, here I'll have 2 over 3B minus 1 over 6. Okay, now this vector here, 2 over 3B minus 1 over 6A is exactly this vector here. So you have negative 1 over 6A, there it is, 2 over 3B, that's it. So this is 3MT. So this is 3 multiplied by MT. So you can see that these 2 vectors, MT and MY, have a point M in common, and one is a scalar multiple of the other. Therefore, the line MTY is in fact a straight line. Okay, so we can say that since MY and MT are parallel, MTY is a straight line. Okay, that's it on number 5. And then number 6, we have, we're told that OABC is a parallelogram. So you should know what a parallelogram, opposite sides are equal in length and parallel. And we are told that OA is equal to A and OC is equal to C. Then we have a point R on OC such that OR, the ratio of OR to RC is equal to 1 to 2, and S is a point on AC such that AS to SC equal to 2 to 1. Then we need to show that OB is parallel to and 3 times as long as RS. So that's what we need to show. Now, first thing with questions like this, if you're not given a diagram, is you need to sketch your diagram. Okay, so I will draw a parallelogram. This is what my parallelogram looks like. Then I put my points. I have O, A, B, and C. I'm told the vector from O to A, OA, is A. So this vector here is A. Then the vector from O to C, so this vector here is the vector C. And then we are told we have a point C. We have a point C, sorry, a point R on OC. So we have a point R on OC. So the point, let me put it somewhere here, this point here, R, and we are told that it divides the line OC in the ratio 1 to 2. So OR is 1 to 2 with RC. And then we have another point S, so that AS, so we need to draw the line from A to C. So we have a point S over here, and the ratio AS of AS to SC is 2 to 1. So that is what we have. Okay, then we have to show that OB is, first of all, it's parallel to RS. Okay, and that it is 3 times as long as that. So what we do is we'll draw this vector here. Use this vector here, RS, and then we have this other vector here from O to B. So there are 2 things we need to show. One, that OB is parallel to RS. And then the second thing we need to show is that RS is equal to, sorry, OB is equal to, OB is equal to 3 times of RS. That is what we need to show. Okay, so with the parallel part, that would also be like showing the other one, because we have to show it's a scalar multiple, and that scalar is equal to 3. Okay, so let's just get into it. Okay, now what we should know about a parallelogram is, like I said before, opposite sides are equal. So and parallel. So if OA is A, then that means CB is also equal to A. So putting this in green to show that this is something that we should know, not necessarily given to us in the question, because this is a parallelogram. And if OC is C, that means AB is also equal to C because they are equal and parallel. Okay, so what we want is to work out OB and then also work out RS and then show that one is a scalar multiple of the other, and that scalar is in fact equal to 3. Okay, I think I should copy the diagram so I don't have to move between pages. Okay. Just want to make it smaller. Okay. All right. So first thing we need to show that, or we need to find OB. Now OB, this is OA plus AB, and this is just equal to A plus C. So that one is pretty simple, very straightforward to do. Now we also need to work out our S. Okay, so you start at R and then you go to S. Now if I'm at R and I want to go to S, I can go from R to O, and then from O I go to A, and then from A I will go to S. Okay, so that's the path that I'm going to take. So I'm here at R. I know what this vector is, so it's a third of negative OC. Then from O, I will go to A, and I know that S, the vector AS, is 2/3 of the vector AC. Okay, so let's write down our path. So we say we start at R, then from R, we will go to O. Then once you're at O, you go to A, so that's OA. Then now that you're at O, what you're going to do is go from A to S. So you will have moved from R to S. So this is just a description. Usually we don't write this, we just go ahead and write the next thing that I'll write there, but it's always good to have, okay, these are my step-by-step directions. Start at R, go to O, then from O you go to A, from A you go to S. Now R to O, so here at R you want to go to A. Now that's in the opposite direction of the direction that this vector is facing, so it'll be negative. So that's a negative. And from R to S, that's 1/3 because R divides the line OC into 3 parts, 1 part from O to R and then 2 parts from R to C. So that's 1/3 of OC. And then from O to A, that's just this A over here. So I'm going to leave it there like that for now. I want to have all the position vectors. And then AS, to go from A to S. So you can see that S divides the line AC into 3 parts. There's 2 parts from A to S, and then 1 part from S to C. So to go from A to S, that's just 2/3 of the way. So it's 2/3 of A to C. Okay, then A to C, I still need to rewrite it in terms of position vectors. So I'm going to keep all this for now. This is -1/3. OC, only because I want to do the substitution all at once in the end, plus OA plus a third. Now from A to C, I must go from A to O and then from O to A. So this is negative of OA because it's in the opposite direction of A to O, and then go from O to C. So now I will make the substitution. So it's minus a third of OC. OC, we say this is C. Then OA, this is A. And then negative OA, negative OA, this is minus A. And then OC, that is C. Okay, so here I have negative a third, and I will have 2/3 C. So that will give me a third C. Then I have A, which is 1A minus 2/3 A. This will give me a third A. Okay, so this is just a third of, I wanted to write the A first, that's why I'm rewriting it, plus a third C. And now look at this, this vector OB. OB is just A plus C, and RS is a third A plus a third C. So I can factor the third out. So this is a third A plus C, and this is a third of OB. So RS is a third of OB, and therefore OB is 3 times the size of RS. So they are in fact parallel because one is a scalar multiple of the other, and it is 3 times as long as the other one because RS is a third of OB. So here this means that OB is 3 times of RS. So it's 3 times as long as RS. So that was number 6. Let's move on to the next one. Okay, with number 7, let me just draw the diagram. Okay, if you have the book, just refer to it. Their diagrams are much better than mine. Here we have A, X, C, O, D, and B. Okay, so we are given this diagram, and then we are told that C and D divide OA and OB respectively in the ratios 1 to 2. Okay, so C divides OA in the ratio 1 to 2. So that's 1 to 2. And D does the same thing. It divides OB, so it's going from O to B in the ratio 1 to 2. Okay, and we are told that AB and BC intersect at the point X. So this point over here is where they meet, and OA is A. So this vector going in that direction, this is A, and then OB, vector going in that direction, that is the vector B. We are told that CX this is equal to KCB, so that means these two vectors CX and CB are parallel, and the scalar multiple, one is a scalar multiple of the other one, and the scalar is K, and we're also told that dx is equal to h of dA. Right, then we have to write in terms of A, B, H, and K the following vectors. So we have A, we start with OD, so the vector from O to D. Okay, so if I'm at O and I want to get to D, I know this is just a third of the way from O to B. That's what it is. So from O to B, we know that is B, so this is just a third B. Then the next one is OC, so the vector from O to C. If I'm at O and I want to get to C, that's again a third of the way from O to A, which is a third of A. And C, I have to find CB, sorry. Okay, so I'm at C and I want to get to B. What I can do is go from C to O and then from O to B. So this is negative of OC plus OB, which is negative 1/3A plus OB is just B, like that. And then D, I have to find DA. So I'm at D and I want to get to A. Okay, so I can go from D to O and then O to A. Okay. Yeah, that's better. So this is negative OD plus OA. Now OD, we worked it out, it was the first one, so we said it's a third B, so we'll have a negative third B, and then OA is just equal to A. So I'm just writing the A first, but you can stop at the previous step, that's also fine. And then E, we have to find CX. Okay, now CX, okay, now we're told that CX is KCB. Okay, and we are told to rewrite this in terms of A, B, H, and K. So CK is KB. K is some scalar. Now CB, we worked it out in part C. So there it is, it's a third A plus B. Now we just substitute. This is K multiplied by CB. So we have minus a third A plus B. This is negative K over 3A plus KB. So this K over 3, I can write it like that because K is a scalar, it's a number. Then F, I have to work out dx. Okay, dx from the question, we are told that dx is equal to h dA, and we worked out d in question D, so we'll just substitute and replace. So this is h multiplied by dA. It's over here. This is a minus 1/3 b. Okay, so this is HA minus h/3. Okay, again, very simple, nothing too difficult there. Then the next question, G. Using your expression for B and E, we have to rewrite OX. So G, we have to rewrite OX, but using our answer from B and E. So B, we said we have OC. B gave us OC, and E gave us CX. So OX, this is OC plus CX. Okay, so OC we said is 1/3 A, and then CX, this is minus K/3A plus KB. Okay, and then we can simplify this, of course. So this is equal to 1/3 minus K/3A. So I have 1/3 minus HK/3A plus KB. Okay, and then the next question, that was G, H. Now H says using the expression for A, or using your expression for A and F, also write OX in terms of your answers from A and F. Now in A, we had OD, and F, we had DX. So I should go from O to D and then from D to X. That's what it's saying. So OX, this is equal to OD plus DX. Now OD, the answer we got in A, that was 1/3 B. And then DX that we got here, it's HA minus H/3B. So this was HA minus H/3B. And then when we simplify it like we did with the previous one, we have HA plus 1/3 minus H/3B. Now you can see here I have 1/3 minus H/3. I can always combine them to make a single fraction because the denominators are the same. Then the next question, that is I. Find H and K and the ratio in which X cuts D. So now this is just solving simultaneously. So we have a vector, remember this is also OX, that is expressed in two different ways. It's expressed here in terms of k and over here in terms of h, but the vectors are the same. Now, if two vectors are equal, it means their a components, the coefficients or the scalar multiples of a, are equal. So this means that a third minus 3 is equal to h, and k is equal to a third minus h over 3. Okay, so I look at the a components, that's this one, and it must be equal to the same one I got in the second question. And this b component must be equal to the one from that one. So I have two simultaneous equations, not a problem to solve. Before I substitute, I think it's always a good idea to simplify. So I'll multiply the first one by 3, and the same thing with the second one. So what I get is 1 minus k is equal to 3h, and 3k is equal to 1 minus h. Okay, then we can do substitution. You can solve them however you want to solve them. The choice is really yours. Use elimination if you want to. Let's see, I have 3h plus k is equal to 1, and then I have minus h plus 3k is equal to 1. Okay, so I will use elimination. That's just my preference. You can use whatever method you want to. The choice is really yours. Okay, so I will multiply the first one by 3, and then the second one I will not multiply by anything. I'll just leave it as it is. So I have 9h plus 3k is equal to 3, and then minus h plus 3k is equal to 1. Okay, so I'm trying to get rid of the k, so I will subtract. I will get 10h. Yeah, this is equal to 2. Get h is equal to 1 over 5. Okay, just checking if what I've done is correct. Let's see. Okay. Okay, 1 minus k is equal to 3h. Yes. And okay. Always good to check if what you've done is correct. Okay, so this looks fine. And k is equal to that. That looks fine. So I multiplied by 3 throughout. So I have 1 minus k is 3h. And then 3k is equal to 1 minus h. Then, what did I say? 3h plus k is equal to 1. Yes. And then 3k minus h. 3k plus h. 3k plus h. Okay, I think that's where the mistake came in. Okay, so from here, what I should have is 3h plus k is equal to 1, and h plus 3k is equal to 1. Okay, that is my mistake. Okay, so this is what I have. Then, like I said, the first one I'll multiply by 3. So I have 9h plus 3k is equal to 3. And then 3h plus 3k is equal to 1. Right, then I will subtract. I will have 6h is equal to 2. Getting h is equal to 1 over 3. Okay. This algebra. Bear with me. Okay, so this is 8h. Yeah, it's been almost 2 hours. I think that's why. Okay, so h is equal to a quarter, and then you can substitute that and work out k. So we know that h is equal to 1 minus 3k. This is 1 minus 3 over 4, which is 1 over 4. So h is 1 over 4, and k is equal to 1 over 4. Okay, so now I've done it correctly. That was the first part of the question. It says find h and k, and then the ratio in which x cuts d. So you see x cuts AD. So we need to work out that ratio. So to do that, we can work out dx and then ax, and then you see what the ratio of dx to xa is. Okay, so we know that dx okay, dx, this is equal to h dA, and this is just a quarter dA, because we know that h is a quarter, and we know that dA, this means that dA is equal to 4 dx. So I just multiply by 4 on both sides. Okay, so we can go back to our diagram. Okay, so dx, this is a quarter of dA. So this is a quarter of this entire length. So that means I need to have a 1 here and a 3 over there. So it should be a 1 here, and then there's a 3 over there. That's how I would get a quarter. There's 1 part over here, and then there is 3 parts over there. Okay, so dx, we said, is a quarter of dA, so it's 1 divided by 4. That's how I get it. So it's 1 to 3. It divides it in the ratio 1 to 3. Okay, so I think this last part wasn't even necessary. Just by looking at this, I should be able to tell. So I write that down. That x cuts or divides dA in the ratio 1 to 3. Okay. All right, so it's been about 2 hours. I'm going to stop here. Like I said, I just want to do all the questions that are in your textbook. So I might make more videos because I see there is a lot of questions, and I went through all of them, solving them. So I would just like to make videos of how you would solve all of them. So hopefully by Friday we will be done with all of this. As you can see, it's not a very complicated topic. So we'll stop here for now.